Hello, this is Robert Gadarian, and we're going to start with another dad joke. While we're still at it, we're going to talk about while. Moving on. Okay. An important thing to do when you're considering writing a program is, can you do it on paper? If you cannot solve it on paper, you cannot solve it in code. That doesn't sound obvious, or maybe it does. I don't know. Some people think that computers have this magical ability to be able to solve problems for us. Well, that's not true. What we do in computer science is generalize problems, solve a general problem, and then make that into some kind of function that we release to the world. But we still had to solve the problem. And even a problem like find a number in a list is something we need to solve and consider and solve correctly. So given the tools we have so far in the course, can we do this? I want to find the number 10, 20, or I want another one, 20, 90. I want to find the number 20 in this list. Well, I would start here and say, are you 20? That's probably an if statement, right? If 10 is equal to 20, we found it. Do we find it? No. Then I want to check this one. Is 20 equal to 20? Well, it is. So then we'd say, okay, well, because we're in computer land, 4, 5, 6, 7, 8, 9. Guess what? Length is 10. So then we'd say, okay, well, 20 is at index 1. Bob's your uncle. But how would we write that code? If index 0 is equal to 20, if index 1 is equal to 20, if index 2 is equal to 20, if index 3 is equal to 20, do I need as many if statements as I have elements in a list? There's got to be a better way. And indeed there is. So in terms of us doing this on paper, we would say, try to find 80. We would say check here, 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 we win. And then we'd say count, probably. This will be our count. Every time we don't find one, we increment our count. So if it's not 10, add 1 to the count, check again. Oh, it's at 1, check spot 1. Is it 20 equal to 80? No, add 1. Now count is equal to 2. There we go, now you can actually see the word count. So this is starting to feel like an algorithm, and that's because it is. This is a very simple algorithm called a linear search. But the problem is that we would need to have n if statements. How big is n? Well, n can approach infinity. Well, dang. Well, that's not going to work. So what we want is a while loop. A loop that runs while a condition is true. That should be capital T true for Python. And this is very much a repeated if statement. If this statement is still true, run again. If this statement is still true, run again. If this statement is still true, run again. So this is very useful for a few things. If there is more data to be processed, while there is more data to be processed, while my user input is garbage. I talked about data cleaning. This is the tool to use it. And really what this is good for is if we are running 0 or more times. That's how many times we can repeat this. And it's important to be able to repeat something 0 times. So this list of data, what if my list of data looks like this? How would my search algorithm work if I didn't have anything in my list? Well, that loop would run 0 times saying, I'm at the end of the list, and quit. I would have to deal with that edge case, and that's an interesting term I will talk more about later here. What if I'm searching for the number 101? I check here, 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 here. Oh dear, we're out of space. Meaning that we are now outside of our list, and that's something we need to check for. So how would we do that? Ooh, time frame not expired is cool. This is how we do frame limiting in a very simple video game context. Okay, so I want to go through a string because strings we know how to index. So let's do that. I want to see if a letter is in a string. So I'm going to have a string. A string. I'm sorry. Is equal to A, B, C, D, E, F, G, H, I. And then I want to go through this and see if the letter Z is in there, for instance. What do I have to do? Well, I have this sense of numbering. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got into the same cell as H there. That's okay. Well, I want to check what's our algorithm. We're actually going to write out every step of our algorithm because that's really important. We're going to check spot 0. Is this what we're looking for? This is our target. Is this target? Well, target is equal to Z, so no, it's not. And then check spot 1, is this target? And that's all the same, ditto marks. Check spot 2, well, this is us repeating at every step. And that's exactly what while loops do. It repeats things for us. So basically, we just have to do this. What if it is? If spot N is the target, what do? We stop. Then we return the spot number, which is a number. We also do have to deal with the edge case. Z is not in this list, right? We're going to get to here. If there is no more list, we need to quit. And maybe return -1. That's a very common thing to do in these search things. That's what find did in strings too. We're arguably recreating that in a poor way. So let's look at what a while loop actually is. It's legitimately while, statement, and then some code. And while, condition. This has a code paragraph, code. So this code, it gets repeated. And while the condition is true. Okay. So let's do some cool things. Let's just jump over to code because that's my happy place. Hopefully it'll become yours. I want to count up to 100. Okay. Well, what is our quote-unquote algorithm here? For every iteration, and that is a single run through the loop, we want to say something. So I'm going to start at 5, just to prove that we can start anywhere. I'm going to end at 100 and count up to 100. I'm a computer scientist. We count up to and not include. While something. Well, what? Well, we need a sense of something current. We need a current number. So we're going to say current number is equal to our start. I could just use our start variable, but that wouldn't feel right in code. While my current number is less than our end, print out our current number. And then we have to add 1 to our current number. That's the cool way of doing adding 1 to a variable. That is the same as current is equal to current plus 1. I do have mixed emotions about the plus equals thing. Print done. This is when the print done things actually make sense. We want to prove that our program's not still looping. So if I would run this, whole bunch of numbers, they're in very small font, from 4, starting at 4, up to and not including 100. So while this is going, we count it up to 100. I'm going to change this to 10 just to limit that. Let's do this search. So our string source is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. There we go. Some keyboard Olympics? Keyboard Olympics. There. Why not? Target is equal to target. What are we searching for? W. Now let's search for C. I'll know if the answer is right then. This is an important concept for debugging and programming too. Know what the output should be before you run it. So if I said W, it'd give me a number. I'd say, well, it's more than 10, probably good enough. But I'm going to give it C because I know that that should be 2. A is 0, B is 1, C is 2. So I'm going to do the same thing. Current index, I'm going to call it index, is equal to 0. While what? Well, while we haven't found it, and while we're still in our range, of our valid range. So I'm going to have an is found is equal to false, because I haven't found it. This is called priming a loop. We're basically setting state to say, this is where we're going to start. Our state is, I have not yet found it, and we're searching at spot 0. So while index is less than the length of our source, so that huge string, then is this it? Well, if we're saying is something true, we're really saying if something is true. If the item at index, source at index, woohoo, yeah, is equal to our target. This is very general, isn't it? Then it is found. Now we know that our whatever index is our good index. I'm going to leave it at this. I'm going to say spot is equal to -1. So if we don't find it, it'll be -1. If we do find it, our spot that we found it is equal to our index. And then we're going to say index plus equals 1, which is literally moving us into the next spot. So I'm just going to run this and see what it says. I kind of hope that it doesn't work, but I think it will work. 27. Oh no, I need to do some debugging. Shucks. Cool. Oh. So I didn't stop the loop when I found my spot. I said in my algorithm, while there's, if the spot N is the target, return spot number. So I actually just kept on going. So that's fine. That means over here I just have to return print out spot. And this should be 3. 2. 0, 1, 2. Counting, indexing from 0. Okay, good. Did this work? Print source index. This is actually kind of neat. We can actually print out some information at every step of the loop. So this will print out A, B, C, D, E, F, G all the way through the alphabet until we found it. And then in here, we can actually say print found it. If that's a string. And, whoop. So here, ABC found it. Hey, great. I found it. Why am I still going? Well, what if we had a couple different C's in our alphabet? Which C would it return as the index of spot. What would spot be at the end? Well, it's going to go through here and say, is this A? No. Is this A? Or sorry, is this C? No. Is this C? Yes. Okay, 2. Is this C? 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 Yes. Track that index. Keep going. Is this C? Yes. Track that index. So I guess this will be 28 because that is the last index of the C. So now the question is, how do I get the first index of C? Well, I want to stop. Well, I can say while the index is in the thing and I haven't found it. Not is found. That's kind of a beautiful thing. While it is not found, keep going. Once it's found, stop. And then we'll get index 2, which is what we want, of where we found our C. This is kind of beautiful. Just remember that index is a number. So it's going to be source 0, source 1, source 2, source 3, source 4. And try that out. Make it feel good. While index is less than length source, this is beautiful. What if our string is nothing? Will this code still work? That is one of our edge cases, which is basically the limits of what our data could be. Can this loop run 0 times? Well, it did. It didn't execute this even once. It never printed out this. It never got to line 26. So while loops are really good at running code an unknown amount of times. In this case, we actually do know, but we could stop at any time. We're going to find out there's another loop called a for loop. It is actually not good at doing this. It's not good at stopping early. It always wants to do the entire set. While loops are good at going 0 to n times, and that n could be quitting early, or it could be running until something happens, which is great. I did the search. Cool. This actually does everything based on variables. And that means that we can use input from the user instead of hard-coded input. But I can change mine because my code is fairly abstract. All my variables are up here. I can change this string into be input. Give me a string with too many spaces. And now that doesn't change anything. And I'm just going to search for the first index of a C inside of any string. And I don't have to change any of this code. If you write your code correctly in an abstract way that solves all general problems, you don't have to change it to do something cool like that. And that's very important. And that's why we make you set all your variables up at the top of your program so that you can easily switch what they are. And if your code is right, it doesn't matter. It's agnostic to that. Priming loop. I mentioned, how do we clean data? Well, say I'm going to change the case here. I'm going to make a new file. I'm going to name it command by or command. And I want to run a well-known command. So we did this last time, plus subtract, and we had if statements. But we just said go away and only ran it once. Well, what if we have some known commands? So this is called priming a loop. And this is running 0 or more times. I guess this is command is equal to input, enter a command. And our program only knows a few commands. So while command is not equal to plus or, oh boy. This is actually a little bit easier. If command is equal to plus or minus, then we want to actually run this again. So we're going to say while it's not one of these. Oops. While it is not plus or minus. That reads a lot better. You have to read it like that, while it is not plus or minus. Then print, hey dummy, plus or minus. Oh, actually lowercase. Then we can say this exact command again. We ask again. We only need to ask again if they screwed it up. And I'll print the command. So if I run this, enter a command. No. Hey dummy, plus or minus only. No. No. Plus. Okay, thanks, bye. Very simple way of doing data cleaning. In the slides, this will keep on asking until you give a number. That wasn't a number. Try again. That wasn't a number. Try again. So this is called priming a loop, where we do this work up front, and then this loop will run, at least, it'll do this comparison, and if it fails, then it can keep on going. And in this case, it will only run this if the user is being a dummy. And this is actually cool. Now we can just start casting our data. We know this is an int. We have proven it by this data is numeric. Well, it is not numeric. Keep going. So that is while loops. Try them out. Try solving a problem. Try searching a string. Try asking for a number. Try asking for 10 valid numbers. Try asking for... Oh, there's so many things you could do. Try searching other things. You can start searching lists soon, which is very nice. I hope you're having a nice day, and I will talk to you later.